Hi, and welcome to our lesson on solving multi-step equations, basically combining the last two lessons that we had. So let's say we have the problem solving 7m minus 17 equals 60 for the variable m. Just like before, we want to isolate that variable m. Notice we have three terms here, so we have to treat those as three separate terms. What I'm going to recommend doing is getting all your like terms on the same side. That being terms without a variable are like terms. Terms with a variable to the first power are like terms. Terms to the with the variable to the second power are like terms, etc., etc. So let's get this 17 on the side with like terms, and we'll make 7m because negative 17 and 17 will cross out if I add them, is equal to 60 plus 17, so 7m equals 77. Now to continually further isolate this variable m, we want to divide both sides by 7 because that's going to give us 1m is equal to 77 divided by 7, which is 11. So my answer 11 is my final answer. So let's take a look as if we had p minus 15 over 9 equals negative 6. Now when you have something like this with a fraction, my recommendation is to always multiply by the denominators to get rid of your fractions. So I'm going to multiply both sides by the denominator of that fraction, which is 9. By doing this, 9 divided by 9 is going to equal to 1. So I'm going to end up with p minus 15 equals negative 6 times 9, which is negative 54. Now, just like we did in lesson 2, I'm going to add 15 to both sides, and I'm going to end up with p equals negative 39 as my final answer. Alright, now let's look at a word problem. We have Hugo here buying a pair of water skis that are on sale for 2/3 of the original price. Let's call that original price P. After he uses a $25 gift certificate, the total cost before taxes is $115. What is the original price of the skis? Well, we know the total cost before taxes is $115, and that's going to equal 2/3 of the original price minus that $25 gift certificate. So this is how we're going to find that original price P. Notice we have three separate terms, so let's get all the like terms together. Let's add 25 to both sides. We get 140 equals 2/3 P. And again, anytime we have a fraction, I'm going to recommend multiplying by that denominator. So we get 140 times 3 equals 2/3 P. So that's going to give me 420 equals 2P. Now I'm going to divide both sides by 2. I'm going to end up with P equals 420 divided by 2, or 210. So $210 was the original price once we took off the 2/3 sale and the $25 gift certificate. Alright, so let's look at this problem. Find three consecutive even integers whose sum is negative 42. So we have here, let's call our first integer n. And then if the second consecutive number is even, we're going to take our original number n and add 2 to it. Because if we added 1, that second number would be odd. Same with the third number. We're going to add 4 to it, because adding 3 to it would give us an odd number. Notice how each of these is the next consecutive even number, with n being the original even number. So let's take all three of those. We have our first one, which is n, our second one, which is n plus 2, And our third one, sorry, that should be n plus 4. Our third integer, n plus 4, we add all these together, negative 42. So we combine our like terms, n, we get 3n. We combine our like terms, 2 and 4, we get 6, still equal to negative 42. Let's isolate the n by first subtracting the 6. We get 3n equals negative 48. Now divide both sides by 3. We get n is equal to negative 16, meaning my first integer is negative 16. My next one is negative 16 plus 2, or negative 14. And finally, my third integer is n plus 4, which is negative 12. So those are my three consecutive integers, and they do in fact add to give me negative 42.